And now we're continuing on with our discussion about IP networking. And we had previously talked about an introduction to IPv6, basic understanding of how it works, and some of the addressing capabilities, and most importantly, the fact that there's more addresses than we could possibly use in the near future. So now let's talk about designing IPv6 networks. So before we get started into that, a little bit more details about how an IPv6 address is actually broken apart. So an IPv6 address is in fact 128 bits in length. So 128 ones and zeros make up the address. The last 64 bits right here is what's called the interface ID. The interface ID is basically what you would see on the IPv4 realm of the host portion of the network address, or in the MAC, on the data link layer, this would also be the MAC address. And in some cases, this interface ID is in fact created based off of that MAC address. So the interface ID is individually assigned to each client or each system on the network. Otherwise, the very first 3 bits right here, that's the 001 that we saw in the previous video, where just simply the 001 portion of IPv6 addresses are handed out. All the rest are still to be done. And then what we have here is essentially our network ID. And the network ID oftentimes is broken up into 2 pieces. We have the global routing prefix that we would get from our ISP. So we would say, hey, Mr. ISP, I need an IPv6 network, and he would hand us a global routing prefix. This can be anywhere from 48 bits up to 64 bits, depending on the size of network that we ask them for. The difference between what we get from the ISP and the interface ID can be used by us to subnet the environment. So we don't have to start stealing from one network or another. We don't have to start borrowing bits from our host networks or from our host addresses in order to create a subnet. We simply ask for a large enough network from our ISP, and then we use what's left over for our subnet ID. We'll talk more about that here shortly. So when we talk to our ISP and we say, hey, Mr. ISP, I need an IPv6 address, they will ask us, how big of an organization are you? Well, if you're a simple home user, your IPv6 address at home, or a small office or a home office, they'll probably give you a 64. So that means there's 64 bits assigned to the network, and then 64 bits assigned for your hosts. Now that's still quite a few addresses available to your hosts, and more than you would ever actually want to be on a physical network, but that's just the way it works. 64 is suggested to be the smallest possible size that you would ever use. You could actually take this 64 from the interface ID and start slicing it out again and making a smaller interface ID so you can have other subnets. But that actually breaks some of the built-in technology for IPv6, so don't do that. Okay, so if I'm a small home office, I will get a /64. If I need more than just simply one network, if I have more than just one room of computers, or if I need to actually subnet my network inside my organization, I would then ask my ISP for /60. Now the cool thing here is, because we have so many IPv6 addresses, the differences between me asking for a 64 and me asking for a /60 is basically the difference between me saying I'm a home user or I'm a business user. That's about it. They may charge you a couple of bucks just simply because that's the way ISPs work, but they'll move you right into the 64. Well, I'm not just a small user, I'm a medium user. Not a problem. Ask for a 56 or a 48, whatever size you need for your environment, you can go ahead and ask for it ahead of time. All ISPs pretty much are stopped at the /32, so they can't give you anything less than that. And then the regional internet registries use a /23. So what this means is, depending on my company size, I can ask for any one of these sized prefixes assigned to me. Okay, well that seems quite interesting, going from a /48 to a /64. That's quite the range that I can choose from, and that's quite interesting, some of the options that it allows me to do. So one of the options it allows us to do is no longer having to subnet based on the binary bits. In IPv4, you actually had to break down the individual bits that you were working with, and you had to subnet based off of them. So there actually was a difference between a /26 and a /27, and which one you chose might make a major decision from your ISP. Because there's so many IPv6 addresses, what we can do is, instead of subnetting on the bit, we subnet on the nibble. Now, a nibble is 4 binary bits. So if I have 4 binary bits, start out 0000, 0001, 0010, 0011, all the way down to 1111. If I have 4 binary bits, then that means I have 16 numbers in a nibble. So that will make more sense here as we move forward. So if I ask my ISP for a /64, then that means I'm using all 4 possible nibbles. Remember, we said you go from a 48 up to a 64. That's 4 possible nibbles. So if I'm using all 4 nibbles, then that means, well, that means I can create one /64 network. Obviously, if they give me a 64, I can only create a 64. Okay, well, that's great. If they give me a /60, then that means I can either use that as one single /60 subnet or as 16 /64 subnets. So you see here the 16 that we're able to use as 64s. Instead of giving us all 64 bits for our network, they're giving us 60 bits for our network, and that last remaining nibble, the last remaining chunk, or the last remaining number, is now available for us to create subnets from. If they give me a if they give me a 56, well, now I have 3 options. Sure, I can create it as just one /56. I can create it as 16 /60s or 64 /256s, and so on and so on. All the way up to a /48, which means I can easily create 65,536 networks without having to do any crazy math. So this is where the plethora of IPv6 addresses comes in, and how it makes our life so much easier. If I know I'm going to be working in, say, a 10-story building, and I want to put one network on each floor of that building, well, basically I start looking at my numbers here from right to left, and I can see a 10-story building, a /60 gives me 16 subnets. So I could easily ask for a /60, give each floor a different network address, and everything is perfectly fine. Now, in reality, if I have a 10-story building, I'm probably going to want to segment each of those floors up into 4 or more segments. Random choice of 4. But I'm going to want more than one segment per floor. So then I look even further over to the left here, and I see, well, if I ask for a /56, that gives me 256 possible addresses, or networks. Well, that's great. That means I could put 20 networks per floor. It's overkill. It's more than I might need, but the plethora of IPv6 addresses allows me to do this. And then the great thing is everything is summarized in one single route. Okay, so how this works. Well, here we have a small business environment, or a small business scenario. And the ISP has given us this address, a /60. So 2001 ACAD 1234 123 /60. This, in this direction, this is 64 bits. 64 bits. of my identifier, my host identifier. Right here, this is my 60 bits from my ISP, which means this right here is what I can use to subnet. And this is where working with nibbles makes life so much easier than working with bits. Because I'm able to use that one letter, that one location in there as my subnet, well, start out with 0 as my first subnet, 1 as my second, 2 as my third, all the way down to F. In hexadecimal goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F to be my 16th subnet. So there we go. I ask for a /60. That gives me immediately 16 networks that I can easily create. And I simply look at that last digit on the network address in order to figure out which network I'm in. And then it's a quick and easy thing for me to realize at that point. All right, well, that's a small business. That's awesome. I just simply look at one bit and I move forward. Well, let's say I'm a medium business. I call up my ISP and I say, hey, I need more than 16 networks. So what's the next chunk I can get? And they say a /56. Now, if I look back at my cheat sheet here, a /56 will give me 156, 16 60s, or 64 256s. Well, that's awesome. All right, so I've got lots of networks I can play with here. Basically what I do, same thing as before. Well, right here, I've got my 64 bits, 64 identifier bits, or host ID bits. Right here, I have 56 bits from my ISP, which now means I have 8 bits or 2 nibbles in order to subnet. Well, that's great. 00, that's my first network. I go 01, 02, 03, 04, 05, all the way up to FF. And that gives me 256 possible subnets. That's awesome. I needed more than 16. I maybe only needed, 20, but I'm able to go ahead and move on up to 256. Lastly, if I'm an ISP or a large business, I can ask for a /48, and basically it's the same thing. They give me 48 bits for my ISP. It's not drawn here, but I do still have the 64 bits for my identifier, and then in between I have 16 bits or 4 nibbles for my networks. Same thing. That's network 1, that's network 2, all the way down to network number 65,536. Okay, great. So how do we do this? Well, let's get a little bit more practice here. Let's say my ISP gives me this address, and I look at it and I see, well, it's a /60. How many /64s are available in a /60? Ooh, I don't know off the top of my head. I actually do, but let's say I don't know off the top of my head, so let's look back at that list here. And I can see, well, here's my /60, /64 subnets. That means I have 16 possible. All right, so 16 subnets possible. What are they? Well, it's going to be this last nibble right here that I'm changing. So it's going to be 2001 ACAD 5678 1840 /64 1841 /64 1842 all the way up to 184F /64. Okay, well, hey, that's perfect. There we go. It actually looks better this way. So yeah, so I saw that it had a /60. This right here, I can see, well, that's 64 bits. So that means right here must be the /60, which means this nibble right here is available for my networking. All right, well, same scenario. I'm given a /56. How many /64s are there in a 56? Look back at my spreadsheet here. /56, that means I have 256 subnets. 256. What are the first four? Well, it's going to be these two guys right here. So it's going to be 00, 01, 02, 03, and there you go. All the way up to FF. Okay, so a practical example. How can we work this in a real world example? So here we have an ISP has given us a 48, which means we have 4 nibbles in order to play with. Remember, each nibble is 4 bits, so 4, 8, 12, 16, 16 plus 48, that's the full /64 that we're looking for. And so we have each of these locations. We have an infrastructure, we have central office, infrastructure, network equipment, servers, and so on. Central office, stores 1, 2, and 3. How do we subnet these? Well, we could simply go, 0000, 0001, 0010, and so, no, that's right, and so on. I'm drawing a lot poorly. However, that's kind of short-sighted. This is where the joys, the power of IPv6 comes in the fact that I have all 4 of these different nibbles, and I can assign an idea to each one of these. For instance, let's say that very first nibble is my site. Well, if the very first nibble is my site, then my infrastructure is going to be like this. I'm going to take the /48 and I'm going to convert it to a /52. So the infrastructure altogether is 0 /52. The central office then is going to be 1 /52, and so on and so forth. Well, that's great. I've gone ahead, I've assigned the site, the physical location, to the very first nibble in my environment. And this makes it real easy because then everything that summarizes up into that /52 route all goes to infrastructure, or to the central office, or to each individual store. Where this comes in handy is on this next slide. Well, okay, we've gone ahead and we've assigned a /52 to our central office, like we just were looking at. We just assigned the 1 to the central office. Now we still have 3 other nibbles to work with, and we need to break this out into manufacturers, finance, HR, and so on, so we can use the second nibble for department. And so we see right here, well, we've got our second nibble here, and that has been assigned to department. It could have been assigned to per floor, and then the third nibble be assigned to department, or vice versa, or however we might want to put it. The great thing is that by asking for these larger networks, we can then not just start dishing out the IPs or the networks as is appropriate, but we can actually plan ahead and say, the first nibble is my site. Well, that gives me 16 possible sites. Do I ever think I'm going to grow more than 16 sites? If so, use 2 nibbles. The next nibble is going to be, department. Well, that gives me the ability to distinguish all of the accounting people, all the finance people, all the executives in each and every single site. Well, maybe I need to have, further subdivision. Maybe one of those is a lab. So, instead of managers or finance, it's a lab. And so then I can break out and say, well, okay, this is lab 1, this is lab 2, this is lab 3, and so on. And so I can start asking for more and more IPs and just ask them for my ISP so that I never have to worry about any conflicting IP addresses in my entire organization or throughout the entire world. So there you go. That is an introduction to designing IPv6 networks.